Maybe, I don't remember what number 4 is.
Why the answer is kilometer per hour?
Maybe I just felt like it. I don't know.
How do you calculate use kilogram and but it's right, but it's
That's right, yeah. Now, what you should do at home, what question have you done? 3. This is number 5.
Yeah.
With the gun.
Yeah.
Okay.
And the block.
And the block. That's an important example.
Yeah.
Important.
Like
Yeah, it's important though. So for your homework, can you try to have up to question 5 done?
okay, I will try, but I'm not sure I will.
But try. Okay, homework, Summer, have at least number 5 done. 1, 2, 3, 4, 5. Okay. Okay, and then tomorrow you can finish everything for the weekend. Yeah? Yeah, but today we'll only do half of this. I won't give you any homework for this because you can look. There's a lot to do in this lesson. It's a big lesson. So we'll do half today and half tomorrow, I think. Oh, you're back. We're going to start the next lesson now. Oh, good. Circular motion. Summer? Yeah. Yeah. No. So this is motion in a circle. Yeah. Okay, let's have a look here. Now, ready, Khalifa?
Yes.
Yep. Okay. A lot to do. Right, Khalifa, you don't say anything because I know you probably know the names of these parts of the circle. Let's see if these 3 guys know. Yeah, don't say anything now. What's this part called? The oar.
Radio.
Shh. Not row.
Radio.
Nearly. Radius. Radius. Radial is the different form. Good, okay, radius, right? And what's this called? Theta, yeah, but what is this? Angle, good. And this? Yeah. And what's this part called?
C.
No. Khalifa, do you know this part? What's called?
Maybe circumference.
Circumference is the whole thing.
Okay.
Just a piece of it. Anybody? It's arc, yes. Yeah, you have to look it up. Theta is the angle, R is the radius, and S is the arc. You should write these words down. Arc, yeah.
Length. Oh,
Arc length. Did you write the names down?
Yes.
Yeah? Okay, continue? Yes? Okay. So, in physics, when we look at movement in a circle, motion in a circle, we do not use degrees. We use a new unit which we call the radian. And the radian, also called the rad, is equal to 57.3 degrees. But to be more precise, you'll do this in maths class later, but if you're wondering, 57.3 is 180 divided by pi, like exactly. But we can just say 1 radian is 57.3. What actually is 180 divided by pi? 180 divided by pi. Yeah, 57.295, so 57.3. Okay. For physics, it's important because the formulas I'm about to use, they only work if you use radians. Have you studied this unit before, radian, in maths class in China?
Yeah.
You seen it before? English.
Forgot it.
She was asking you, what is it in Chinese? And you say, no, go, English only. Yeah?
Actually, just know this.
You know it?
Know this about a little things.
Yeah.
But I
In one circle, there's 360 degrees.
not very useful.
Not very useful. Very important though for physics. Yeah, I can show you. It's where is it here? It's shift and where is it? This button here. There's the pi symbol.
Okay, this one, 10x.
I guess so. Yeah. Do you have it on this calculation? There it is. There. Shift pi. Yeah. Okay. Continue.
Yes.
Do you have this definition? 1 radian is 57.3 degrees.
Yes.
Yeah? Now, let me just, before I continue, open up this here. Okay. So, you'll do this with Joan in maths class in trigonometry. What are you doing at the moment in maths class? Quadratics and cubics still, yeah?
Yes.
You haven't started the next chapter. Pascal triangle, okay, you've done that then, okay. Continue? Yeah. So here's a small question I want you to do for me now. I want you to change 0.25 radians into degrees, and I want you to change 30 degrees into radians. You got it? Do you mind? Thank you.
Oh.
You got both? Yeah. So what did you get for the first answer, Gail?
14.325.
Sounds right. So it's 0.25 times 57.3. So that is 14.3 roughly degrees. Now what about the next answer?
0.12.
So it's 30 divide 57.3. So you got 0.52. So about half a radian. Alright, that's okay. Yeah? Continue? Yeah? Right, we've seen two types of motion so far in physics. The first one is SUVAT motion in a straight line.
Yes.
And then like a car. And then the next one is SUVAT in 2 dimensions. Now don't say it, because I know you know this word. What's this? What was this lesson called?
Animals, things.
Now give me English, man, English. Begins with a P. Oh, you might not know it actually, because you weren't in on this lesson. So what do you call this type of motion? Beginning with a P. Not fuck. Go on, yes? Yes. Projectiles. Projectiles. Yeah, you knew this one?
Yeah.
Yeah. Yeah. You should at least know the names of the lessons you're studying.
Okay.
It's a minimum. I'm actually kind of angry. Okay, so like a projectile fired through the air. Okay, now we'll look at a new type of motion, motion in a circle. So this is motion around in a circle like this, okay? Firstly, what makes something move in a circle? So just here, if something is moving in a straight line, like from here to here, it has an acceleration because there's some force here, okay? If it's moving like this, it's because there's some force pushing it down here, pulling it down, yeah? So what makes it move in a circle? The definition is, if an object is undergoing circular motion, so if it's moving in a circle, then there's a total force acting on the object perpendicular to the velocity and towards the centre of the circle. So let me just draw what that means. If something is moving in a circle, it's because there, hang on, there it is there. There's a force which is perpendicular to the velocity, so perpendicular, and the force is to the centre of the circle. This will make it move in a circle, okay? If the force was not to the centre, then it would move off the circle, okay? So you need 2 things: the force to be to the centre and to be perpendicular to the velocity. Then it will move in a circle, okay? So you need to write all of this down, please. All of this down. Got all that, Gleefer? Yeah. Okie dokie. Got that? Yeah? Okay. So I drew that already. Actually, yeah, did you draw this as well? I think you should draw this as well. Yeah. Got that? Yeah. Okay, continue. Yes. Right. So, centripetal force is the force that makes it move around the circle. So this force here has a name. We call this force the centripetal force. The centripetal means like center. Okay, so actually that's a little bit much. I think it's enough to just write this. Centripetal force is the force that acts on the body that revolves around the center. So it's the circular. It's what makes the circular motion. In other words, this is called centripetal force. Are you pop out for a minute? Yeah. Okay. You got that?
Yes.
Yeah. Okay. The next one, F equals ma. In fact, if m equals 1 kilogram, then F would equal A, right? If m is 1, for example. So basically, the next sentence should not surprise you. You have something called centripetal acceleration. And if this is moving in a circle, the V is here. Where's the A? Which way does the A point? Which way? Here, 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 here. Which way is the acceleration? The A.
I think it's the same way.
Same as V?
So
It's here. Because Newton said, remember, F equals ma. So if the F is here, then the A is here also. Because in fact, look, if m equals 1 kilogram, then F and A, they're actually the same. So if the F points here, then the A also points here. So like where there's the F, there's the A. And where there's the A, there's the F. They're in the same place, in the same direction. Okay? So we call this A the centripetal acceleration. It's the acceleration when you revolve around a circle. It's called the centripetal acceleration. So you need to write this down. It's a centripetal acceleration. Yeah? Got that? Yep. Good. Right. Angular velocity, the omega. This is the rate of change of the angle with respect to time. So let me just explain that here. So let's imagine it starts here, and then let's say 1 second later it moves 1 radian. Remember, 1 radian is 57 degrees. Okay, and then 1 second later it moves 1 radian again, and then another second it moves 1 radian. We would say omega equals 1 radian per second. So it's like how quickly the angle changes. This is called the angular velocity. It's the change of the angle per time.
Theta per 10.
Yeah, very good. It's the theta, the change in the theta over the time is the omega. So this here is delta theta. Yeah. Good, okay, so you can write that down. Yeah, Ben, you've seen this before?
Yeah.
Yeah?
I don't like
In Chinese?
it.
Yeah.
I don't like it.
Maybe you'll like it second time. Yeah?
Yeah.
Got that down? What's wrong, Gav?
I don't like this also.
Huh?
I don't like this test.
Oh, well, maybe you'll like it second time. Continue.
Okay.
So, the units, of course, are radians per second, obviously. Yeah. All right. Next now. We did the example. Yeah. Periodic time. What do you think this is?
Delta T.
Not delta t. No, not quite. Yeah, what would you say that is, Go?
I know that in Chinese.
Yeah, we'll say it in English.
Like,
The periodic time is the time for one cycle.
yeah.
Yeah, the periodic time is the time taken for one orbit. Will we close the door? Yeah. Is Khalifa outside?
Yeah. Maybe.
Okay. Of course, the units are seconds. So it's the time for one orbit. Got that? Yeah? Yeah. Okay, so for example, if the t is 2, then it takes 2 seconds to complete an orbit. Right, now the unit per second is a special unit. So this unit here is given a special name. It's called the hertz. Hertz. So 1 per second is called 1 hertz. 1 hertz equals 1 per second. Okay, and the reason we have this unit is for frequency. Yeah, frequency, you know it?
I see that.
This here.
Before the day chemistry class.
Oh yeah, Lorraine said she did waves with you.
Light.
Light waves.
Yeah.
Yeah. So what's frequency then? What's frequency?
Frequency.
Hmm?
I don't know.
What's frequency? You know it? Gal?
Yeah.
What's frequency?
Like, I don't know how to explain
Like
it.
the
But
sound, sound bigger, the sound you know.
It's to do with sound,
like
yeah.
speed.
It's like a speed. So the frequency means how many per second. So if in 1 second it goes twice, we say the frequency is 2 hertz. If in 1 second it goes 3 times, we say the frequency is 3 hertz. So the frequency is the number of orbits in 1 second. The units is per second. So for example, 2 hertz means 2 orbits. And what would 0.5 hertz mean? Half, yeah, in 1 second it goes half. Okay, if you can write both these boxes down. Thank you, Summer. You wrote both boxes?
Yeah.
Good. How many pages did you miss? What was the last thing you wrote down?
Circular motion?
Centripetal?
Yes.
You missed half a page?
3 or 4. 4.
Yeah. How much space does he need to leave? About half a page? Leave half a page in your book. You got this, Ben? Yeah. We're waiting for Go, yeah? Yeah. You got it? Yeah? Okay. So now, some formulas. So the first formula is T equals 1 over F. This is our first formula. You want to write this down? T equals 1 over F. That's the first one. Easy formula. Next formula is omega, the angular velocity, equals 2 pi over T. Yeah. Got that? That's formula 2. Formula 3. V. Now just to be clear, the V is this V here. The speed equals omega r. And what's the r? What's the r called? Radius. Radius. Yeah? No, they're different thing. Continue?
Yeah.
Number 4. Now, the acceleration equals v squared over r. Yeah, that's number 4. Now, before I continue, I want to do a small proof of this. A small proof. Can I go down? So look, here's something moving in a circle, and we said the acceleration is this way, okay? And we don't know what the formula is for acceleration. So acceleration equals, we don't know, okay? Now, we think if this is moving faster, is this bigger or smaller? Maybe it's bigger, or maybe it's smaller. We don't know. It's probably bigger. But we think that the A depends on the V, but we don't know the power. Maybe it's v minus 1, maybe it's v2, we don't know, okay? Also, do you think if the radius was different, it would affect the acceleration? Yeah, it should do. It should do, yeah? Remember Newton said F equals ma. F equals ma, okay? If you have a small circle, do you think the F is different than for a big circle? Yeah. Maybe it's bigger, maybe it's smaller. We don't know, okay? So here we think the radius is in here, n. All right. Now the way we can figure out the m and the n is by looking at the units. What is the unit for A? Meter per second squared. What is the unit for V? Meter per second. But we have oh well, I don't want to use m because that's confusing. I'll use a C. C and C here. Okay, and what's the unit for or? What's the unit for or? Meter. So that's meter n. Okay, so you get m over s squared equals m c plus n over s c.
Okay.
Yeah, now you can kind of see what the c must be. What must the c be? 2. Okay, so you know that the c here is 2. Okay, so then you can see that 2 plus n, that must be the same as 1. So then what does the n equal? Minus 1. And what does the c equal? 2. So here, this is v squared, the c is 2. And what's the n? Minus 1. So that's over or, which is exactly what I say here. So the reason for this is so the units are correct. This is the only formula you can have for the A. So it must be this. Yeah? Now you don't need this for the exam. I just wanted to explain why this is the formula, what the reason is. And the reason is because of the units. Is one reason. Omega? No problem. So, this angle here is 360 degrees, or that's 6.28 radians, which equals 2 pi radians. So the omega would be the total theta over the total time, which is 2 pi over t.
Maybe not too high.
Yeah, but why not?
4 pi.
4 pi, then it'd be 4 pi over 2t, because this t is for 1.
Oh.
So 4 pi means it does this.
Oh.
Yeah? No? Okay. Trust me. Okay, next formula. Oh no, that's all the formulas for this one. Okay. Now just the last one. The last one, if you can write this down. A equals v squared over or, but v equals, what does v equal?
Huh?
What's v equal to? Omega or. So you can have A equals omega squared or squared over or. What does this equal? Omega squared or. So there's another formula for A, omega squared or.
What is omega, please?
The angular velocity. Maybe you are out for this one. Yeah. Okay. You got that? Continue. Oh, and of course, you can say F equals ma. So you can say F equals m omega squared or F equals m v squared over or as well. Yeah, maybe you could just write this as well. Yeah. Got that? Got that go? And Ben? Yeah? Okay. Okay? Okay. Right. So this was my plan because this lesson is quite a big lesson. And these examples are quite take a little bit of time. So I have 1, 2, 3, 4, 5 examples. So what I'll do is we'll just do one example, a simple baby example, which is this one, and then we'll just finish. And we'll continue this lesson tomorrow. So a CD, you all remember a CD?
Yeah, I know CD.
You still have CDs?
No.
Okay. iTunes? What do you use for music? iTunes, Spotify?
Net easy music. It's
What?
a kind of Chinese.
Oh, it's a Chinese thing, okay. What do you use?
SoundCloud.
Oh, SoundCloud, I know, yeah. So, this here is a CD. It's a CD, and it spins at 500 RPM. Who knows what RPM means?
Rad.
Yeah, go on. Go on.
Really?
No, what were you going to say?
Or you say rad pal meter.
No, what were you going to say?
I don't know what I said.
Rad pal meter.
No, nice try though. No, don't look it up,
It's
Revolution?
Yeah,
Revolution
Yeah.
per minute. Per minute.
per minute. It's
Yeah,
not per-
this is what
per
people use in engineering
second. It's
when they're
not-
building
Oh,
machines. You know, like a car. You know, when you drive the car, you have RPM
yeah.
on the dashboard.
It's
You know-
not per second.
No, per minute.
Oh,
So, like when you're driving, you have, you know, when you put your foot down, you hear the engine rev.
Some people say range per meter.
No, revolutions per minute. Okay, anyways, I want to know what's the omega. Okay, so look, if it's 500 per minute, then that means it's 500 over 60 per second.
yeah.
So that means the frequency is 500 over 60.
Yeah.
Okay? So the time equals 1 over f. So that's 60 over 500.
Yeah.
And what does the omega equal? 2 pi over t. So that's equal to 2 pi over 60 over 500. So that is 1000 pi over 60. So what's that, please, on the calculator? That's 100 pi. That's 314 over 6, isn't it?
52.35.
So 52.4?
6.
So 52.4?
Yeah.
Let me see.
50.4.
Or 4.
52.4, yeah. 52.4 radians per second is the omega.
What's the unit?
For what?
Is 500 per minute.
500 per minute.
The unit is turns per minute. Number of turns per minute. That's what this is. So it's basically per minute is the unit. It's 500 per minute. Just per minute.
Like 1 per 500.
No, I'm not so sure. It's just the unit is just per minute. That's all. Just that's the unit. So you're saying 500 per minute in 1 minute. There's 500. Not happy. It's kind of like per second, which is hertz,
Oh,
except there's 60 of them.
okay.
Yeah. Yeah, this is okay. Look, just write this example down and then we'll finish and we'll continue tomorrow, this topic. You got everything written down? Yeah, you can go then. You got this, Gal? Somewhere?
Yeah.
You got it, Ben? Are you sure? Yeah?